These are the video notes for lesson 25, congruence criteria for triangles, angle, angle, side, and hypotenuse leg. For the first part, we're going to do this opening exercise proof as practice. It says, write a proof for the following question. Once done, compare your proof with the neighbors. Given DE is equal to DG, EF is equal to GF, and we're trying to prove that DF is the angle bisector of angle EDG. So to start, I'm going to make a table. I'm going to do statements on the right and reasons on the left. So statements. Reasons. Then I'm going to look at my picture, look at what I've been given, and see if I can find any congruent angles and sides to match up. And looking at the given, I have DE is equal to DG, so I'm going to put congruency marks through those two sides. We have this side is equal to this side. Then I have EF is equal to GF, so I'm going to make congruency marks for those two sides. And then I'm trying to prove that DF is the angle bisector of angle EDG. So remember what a bisector does. It cuts something into two equal halves. So what I'm really trying to prove is that angle EDF is equal to angle GDF. So I'm going to mark those in red because we haven't proved that yet, but that's where we're working towards. So we have this angle is congruent to that angle. That's what we're trying to work towards. And then I notice that I have two triangles and a shared side, which is side DF. So I'm going to mark that with some congruency marks. Okay, so I think I have a strategy. I'm going to do triangle DEF is congruent to triangle DGF, and then that'll make all the corresponding parts congruent, and then I can show that DF is an angle bisector. So to start, I'll do my given. I have DE is equal to DG, and I have EF is equal to GF. I'm just going to do it in one statement. There's my given. And then I had DF is a shared side, so it's equal to itself by the reflexive property. So DF is equal to DF by the reflexive property. And then I have enough information with those two statements and reasons to show that the triangles are congruent. So I'm going to go ahead and do that. I have triangle DEF is congruent with triangle, and I need to make sure I match it. So D matches with itself, so D matches with D, E matches with G, and F matches with F. And that was because of side, side, side. And then since those two triangles are congruent, all the corresponding parts are congruent. So I'm going to end up with angle EDF is congruent with angle GDF, and that's because corresponding parts of congruent triangles are congruent. And then for my last statement, which is what I'm trying to prove, and we're trying to prove that DF bisects angle EDG, and that's just a definition of bisector. Okay, these notes are about two different congruency criteria. We're doing angle, angle, side, and hypotenuse leg. So I'll start with angle, angle, side. So angle, angle, side, or AAS for short, means that we have to get two angles or two pairs of angles to match up, and then a pair of sides to match up. And we need to make sure that the sides are not in between the two angles, or that's a whole different congruency criteria. That's angle, side, angle. So if I do two pictures or one picture of two triangles, and what it would look like for angle side, it would look like this. We would have one pair of congruent angles, we would have another pair of congruent angles, and then a pair of congruent sides. So sort of like that. Okay, and then the second criteria that we're going to study today is HL, and that stands for hypotenuse and leg. And since there's only a hypotenuse if you have a right triangle, this only works on right triangles. It only works on right triangles. Okay, so let's do two pictures of that, or two different triangles. Okay, here's one triangle. It's a right triangle because here's the 90-degree angle. Then I have another triangle. It's also a right triangle, and here's a 90-degree angle. Alright, just to review, how do we find the hypotenuse of a right triangle? You find the 90-degree angle, and you draw an arrow right through the middle of it. It's going to point at the hypotenuse. So the two arrows are pointing at the hypotenuses for those two triangles. So we have one hypotenuse right here on this side, and we have one down here on this side. And to be HL, we have to have matching hypotenuses. So this has to match with this. And then one of the other two pairs of legs have to match up. So we could either do this pair or we could do the other pair. It doesn't matter as long as we have matching hypotenuses and one pair of matching legs. Okay, and then we could say that triangle A is congruent with triangle B by HL. Alright, let's do some examples. On example 1, I have given that BC is perpendicular to CD, AB is perpendicular to AD, the measure of angle 1 is equal to the measure of angle 2, and we're trying to prove that triangle BCD is congruent to triangle BAD. So I'll start by marking up my picture with any congruency marks that I can find. So first of all, I have BC is perpendicular to CD. When two lines are perpendicular, they're going to intersect and make 90-degree angles. So I'm going to get right angles where those two lines intersect. So BC is perpendicular to CD. That's going to give me a right angle right here. And then I had AB is perpendicular to AD. That's going to give me a right angle right here. And then the next thing I have given is that the measure of angle 1 is equal to the measure of angle 2. So measure of angle 1 is equal to measure of angle 2. Then I have BD is equal to itself. I can see it's a shared side, so we'll mark that. And it's also the hypotenuse, so that we might be able to do HL. And usually that's what you look for first when you have right triangles. You want to try to do HL. But for this one, HL is actually not going to work because we don't know anything about the legs of this triangle. We know that the hypotenuses are congruent because they're shared side. It's the same side on both. And actually what I have on this one is I have matching angles right here. They're both 90 degrees. I have matching angles right here. And then I have the shared sides, so they match. So this one, those two triangles are congruent by angle, side, and not HL. So let's go ahead and write down the proof. So these statements on the right and then reasons on the statements on the left and reasons on the right. And my first statement is always what's been given. So I have BC is perpendicular to CD. It's given. Actually, let's do both of the perpendiculars. So we have AB is perpendicular to AD. And then we had angle, or measure of angle 1 is equal to the measure of angle 2. And that was also given. When I was looking over the homework from last week, I saw a lot of you put given as down on the last part. Given is always first. It's always the first part of the proof. It's never in the middle, or it's never last. It's always the first part. Alright, so what do I have next? I need to show that angle BCD is equal to angle BAD. And to do that, first I have to show that they have the same measure. So this one's going to take a little bit of work to it. So first I'm going to write down that angle BCA is equal to 90 degrees. And that's because perpendicular. So that's the definition of perpendicular. And we're going to do the same thing for the other side. So we have angle BAD is equal to 90 degrees. And it's the same reason. So definition of perpendicular. Okay, and then they're equal to themselves because they both equal 90 degrees. You can just substitute, or you can do the transitive property. So we're going to have BCA is equal to BAD. Alright, and then I had angle, or side BD is a shared side, so it's equal to itself by the reflexive property. So BD equals BD. And that's going to be reflexive property. And then I have enough to do my congruency statement, which is that triangle BCD is congruent to triangle BAD. And that was because of angle side. Okay, number 2, we have more perpendicular lines. We have AD is perpendicular to BD, BD is perpendicular to BC, and AB is equal to CD. We're trying to prove that triangle ABD is congruent to triangle CDB. So to start, I'll start like I always do. I'm going to mark up my picture with any congruencies I find. So if AD is perpendicular to BD, that means I'm going to get a nice 90-degree angle right here. And then I had BD is perpendicular to BC. So BD and BC is going to make a right angle right here. And AB is equal to CD. So AB and then CD. And then I had a shared side. BD is a shared side, so I'm going to mark it. Okay, so let's look at it and see what I have. Well, to start with, those two sides at AB and DC, those are both hypotenuses. I can tell because I'll just draw the arrow right through the right angles. So this is the hypotenuse for triangle ABD. And if I draw the arrow through this right angle, this is the hypotenuse for triangle CBD. Alright, so we have matching hypotenuses, and then BD is shared sides, so it's also one of the legs of those triangles. So we have our HL with this one. Alright, so let's write it down as a proof. We'll do statements. And then reasons. Start with what's given. So we have AB or AD perpendicular to BD. BD is perpendicular to BC. As given. And then I had AB is equal to CD. That was also given. Okay, and then let's go ahead and write down the shared side. So we had BD is equal to itself. That's because of the reflexive property. Okay, so let's go ahead and do our next part, which is that angle ADB equals 90 degrees. And that's because of the perpendicular lines. So definition of perpendicular. And then we had angle DBC equals 90 degrees. And it was also because of the definition of perpendicular. Okay, so those two are equal to the same thing, so they're also equal to each other. So we have angle ADB is equal to angle DBC, and this time we'll do it because of the transitive property. You can really do it either way. You can do substitution or transitive property for these. Okay, number 7. All right, so we have our right triangles, and we have our hypotenuses are congruent, and we have legs that are congruent.